Welcome everyone. In this video, we'll be discussing some mind-blowing space news that will challenge everything we thought we knew about the universe. From mysterious galaxies that defy current understanding to bizarre exoplanets and new technology that could change space exploration forever, you won't want to miss a second of this incredible journey through the cosmos. So buckle up and get ready to expand your mind as we explore the latest discoveries from the final frontier. Russian space agency Roscosmos is preparing to send a rescue ship to retrieve 3 astronauts whose return vehicle was damaged by a meteoroid. The Soyuz MS-23 spacecraft was delayed after a supply ship docked at the International Space Station leaked coolant. The Soyuz MS-22 spacecraft had been hit by a tiny space rock and began leaking coolant in mid-December, after it had flown Russian cosmonauts and a NASA astronaut to the ISS. An empty spacecraft was scheduled to bring home the 3 astronauts in February, but the launch was postponed after a Russian supply ship docked at the ISS also leaked coolant. The new launch date for the rescue ship was recommended by chief designers for February 24th and successfully docked on the ISS Saturday the 25th. MS-22 will return to Earth without crew, and MS-23 will replace it to bring the crew back to Earth. Planned return date is set to September 27, 2023. Moving on, it's been discovered that Jupiter's moons have an aurora that's 15 times as bright as the one we see on Earth, and they are red. The James Webb Space Telescope has captured images of Jupiter's aurora, with scientists also observing faint aurora in the Galilean moons using the Keck Observatory's high-resolution Echelle spectrometer, HIRES, and other high-resolution spectra. The observations show that the oxygen content in the atmospheres of Europa, Ganymede, and Callisto is the main constituent and that the moons all show similar oxygen aurora, much like the aurora borealis and australis seen on Earth. The oxygen is caused by photolysis, the process where water ice sublimates and is broken down by solar radiation into hydrogen gas and oxygen, and sulfur dioxide spewed from Io's many volcanoes interacting with solar radiation. Sodium chloride and potassium chloride also contribute to the atmosphere, leading to yellow, orange, and infrared glows. The observations also revealed that the magnetic field causes aurora to vary in brightness as Jupiter rotates. Next up, this one might make us have to rewrite the history books. Astronomers are puzzled by a handful of objects found in data from the JWST, James Webb Space Telescope. These objects are thought to be half a dozen galaxies that appear to be massive and well-formed, despite being only 500 to 700 million years old and originating just after the Big Bang. According to current cosmological models, there wasn't enough time for them to have grown to such a state of maturity. This discovery challenges our understanding of the evolution of the universe and suggests that we may be missing a key step or two. The 6 galaxies are more than 12 billion years old and have sizes up to 100 billion times the mass of our Sun. One of the main objectives of the JWST is to peer farther into spacetime than any other instrument, and it studies the universe in infrared, which is perfect for detecting the light that has traveled for billions of years to reach us from the early universe, stretched out into longer infrared wavelengths by the expansion of spacetime. The research team has been scrutinizing their work for errors but has found none so far, indicating that our understanding of cosmology or galaxy formation in the early universe may need significant revision. The next step will be to obtain spectra of the candidate galaxies to reveal their natures, distances, and sizes in more detail and, hopefully, their chemical composition. Next, astronomers have discovered a Jupiter-sized exoplanet called TOI 5205b that is orbiting a tiny red dwarf star named TOI 5205. This discovery is quite unusual as it goes against the current understanding of planet formation. Generally, a gas giant planet needs about 10 Earth masses of rocky disk material to create a planetary core that can accumulate gas to create a giant atmosphere. This process needs to occur relatively quickly, before the baby star blasts the remnants of the disk away. However, in the case of TOI 5205b, astronomers observed that its host star is almost 4 times the size of the Jupiter-sized exoplanet, which is quite unusual. This pairing is one of the first such findings, and astronomers are not entirely sure how such a strange pairing came to be. Red dwarfs are the smallest main sequence stars that we know of. They are low mass, brightness, and heat, which means they burn through their hydrogen stores so slowly that their projected lifespan can be in the trillions of years, way longer than the current 13.8 billion year age of the universe. Although red dwarfs are the most numerous stars in the Milky Way, just 240 of the 5,250 exoplanets confirmed at the time of writing are orbiting red dwarf stars, and only a dozen or so of them are Jupiter-sized or larger. TOI-5205b was discovered based on transits. This passage dims the star's light, and if the star's intrinsic brightness is known, astronomers can calculate the exoplanet's size. The gravitational interaction between the star and the exoplanet also causes the star to wobble slightly on the spot, and measuring this wobble allows astronomers to calculate the exoplanet's mass. Moving on. Sending a lander to Venus is an engineering challenge due to the planet's extreme environmental conditions. The surface temperature is hot enough to melt lead, the atmosphere is corrosive, and the atmospheric pressure is equivalent to being 5,000 feet underwater. Additionally, previous missions to Venus have only lasted 2 hours or less due to these conditions. However, NASA and Advanced Thermal Batteries, Inc., ATB, have created a battery that can operate at Venus's temperatures for an entire solar day, which is approximately 120 Earth days. The battery is based on short-lived thermal battery systems used for powering smart missiles and uses specifically designed chemistry and structural materials. The battery is a significant accomplishment that may provide a new energy storage device for future exploration in harsh environments across the solar system. While solar panels and radioisotope thermoelectric generators are not viable options for powering a Venus lander, this advanced type of battery technology may be the solution. The new type of thermal battery is part of the long-lived In Situ Solar System Explorer (LLISSE) program, and a complete prototype Venus battery system is expected to be demonstrated in the next 18 months. Next, astronomers have discovered evidence of 2 pairs of dwarf galaxies that contain giant black holes on a collision course with each other. The first pair, known as Mirabilis, is about 760 million light-years from Earth, and the other, called Elstir and Vintoi, is about 3.2 billion light-years away. While black hole collisions in large galaxies have been observed before, it is much more challenging to observe them in dwarf galaxies due to their smaller size and fainter light signatures. The discovery was made possible by combining data from multiple telescopes, including X-ray, infrared, and optical observations. These galaxies and their black holes could provide clues about the first galaxies, their black holes, and how they formed over billions of years into the larger galaxies that exist today. Moving on to some tech news. Google's quantum computing research has achieved a major milestone by reducing error rates, a long-standing obstacle for the much-hyped technology. Quantum computers have been touted as revolutionary due to their ability to process a massive number of potential outcomes simultaneously using qubits, which can represent both 0 and 1 at the same time, thanks to a phenomenon known as superposition. However, high error rates caused by a phenomenon called decoherence have frustrated scientists, who want to ramp up their experiments. Google's team has now demonstrated for the first time in practice that a system using error-correcting code can detect and fix errors without affecting the information. While the result is not perfect, the development represents a key scientific milestone for the future of quantum computing. And lastly, we have 2 news stories from the physics department. But before that, please consider hitting that subscribe button if you like this type of content, and giving the video a thumbs up. It helps a lot. Researchers have discovered 2 new forms of frozen salt water that could help solve the mystery of the solar system's ice-covered moons. The atoms in hydrated sodium chloride arrange themselves in never-before-seen structures when subjected to high pressures and low temperatures. These structures have a much higher proportion of water molecules than salt, which could explain the strange chemical signature of a substance on the surface of Jupiter's moon Europa. The researchers compressed a tiny blob of salt water in a diamond anvil cell under extremely cold conditions, generating pressures up to 25,000 times Earth's atmospheric pressure while lowering temperatures to -123 degrees Celsius. 2 new arrangements of salt and water molecules emerged, which are very different from what is seen naturally on Earth and are consistent with the watery chemical signatures observed on the ice moons. This discovery could solve the long-standing mystery of the unidentified hydrate phase at the surface of Europa and Ganymede. So the last piece of news for this week is, scientists have made the most precise measurement ever of any elementary particle's property. The electron magnetic moment was measured, which is a measure of the strength of the magnetic field carried by an electron. This property is predicted by the standard model of particle physics, and it's the most precise prediction made by that theory. By comparing the new measurement and the prediction, scientists gave the theory one of its strictest tests yet. The result agrees with the standard model's prediction to about 1 part in a trillion. The new measurement is more than twice as precise as the previous measurement, and it was obtained by studying a single electron for months on end. The stalwart standard model has stood up to a barrage of experimental tests for decades. But scientists keep looking for cases where the standard model breaks down. Thank you so much for watching this week's edition of Science News. See you next week.